Alright, welcome to video lesson 7.5, using the Pythagorean theorem. Our learning objective today is to use the converse to the Pythagorean theorem and the distance formula. The converse of the Pythagorean theorem. If the equation a squared plus b squared equals c squared is true for the sides of a triangle, then the triangle is indeed a right triangle. So here's our first example. Tell whether each triangle is a right triangle. So here we're going to start out with the Pythagorean theorem. A squared plus b squared equals c squared. And then you're going to replace your variables a and b and c because we have those variables and we know them. So a will be equal to 9, b will be 40, and c is going to be 41. And now the square root of 9 is 81, plus the square root of 40, which is 1,600, and the square root of 41, which is 1,681. Now simplify out your left side of the equation, which will be 1,681. And is that equal to 1,681? Yes, it is. So therefore, it is a right triangle. Okay, now the second example. So we're going to start out just like we did with the other one. A squared plus b squared equals c squared. And over here, these are your two legs because this one is longer than, or your hypotenuse is longer than your two legs. So A will be 18, or yeah, 18, sorry, and B is going to be 12, and C is going to be 24. And now you just simplify it out. So 18 squared is going to be 324, 12 squared is 144, and 24 squared is 576. And now you just basically simplify everything out, and it'll be 468 on this side, and 576. So are those two values equal, is the question. No, they are not. So this little triangle up here, no, it is not a right triangle. These are just a few quick notes that you should definitely take in mind. The Pythagorean triple, it's a set of three positive integers, a, b, and c, where a squared plus b squared equals c squared, just like we were working on. So an example is 3, 4, 5. Now since 3 squared plus 4 squared equals 5 squared, it is a Pythagorean triple, and it's 3, 4, 5. And then if you double this, it'll be, for example, 6, 8, and 10. So if all those are squared, yes, they will be equal. So this side will be 100, and the other side will be 100. So when you're using this, always substitute the length of the longest side for C, your hypotenuse. If your hypotenuse is C, then you'll figure it out. But you need to make sure that your longest side is C, or else this will not work. Okay, so now we're on to the distance formula. To find the distance between any 2 points on a coordinate plane. So you're going to use this formula. So the distance d between any 2 points, x1 and y1, and x2 and y2 is given by the formula. So if you'll just write this down and keep this in mind, this formula right here. That's, if as long as you know all these, we should be good. So yeah. Now I'm gonna let Miss Pichette take over now, cause I'm running out of time here. All right, have a great day.
Hi.
Thank you, Alex, for doing part of the video today. And I will resume with example 2. When you're using the distance formula, first we're going to let the first set of coordinates, x1, x2, be 1, 5, which was the first list of coordinates, and x2, y2 be the second set of coordinates, negative 4, 2. Now we'll write the distance formula. That equals the square root of the difference of the x's squared plus the difference of the y squared. Now we're going to substitute the values into the equation. So the distance equals the square root of x2 is negative 4 minus the first y, or first x, squared plus the difference of the y2, so 2 minus y1, 5 squared. Okay. Then we need to simplify that, right? So when we actually do that, negative 5 minus 1, negative 4 minus 1 is negative 5 squared plus 2 minus 5 is negative 3 squared. And then we need to evaluate the powers. Okay, so that will be 25 plus 9. And then we need to just finally add. Okay, and when we do that, and get this out of the way, then we have the square root of, okay, sorry, I did that a little bit funny. This, gotta look back up one more time. Okay, and 25 plus 9 is going to be 34. That's going to not come out exactly evenly, okay? So we can just keep it as the distance equals the square root of 34, or we could write an approximation of that using our calculator to the nearest tenth. But we could keep it like that for now. All right. In example 3, it says we're designing a football play in which a player runs down the field, makes a 90-degree turn, runs to the corner of the end zone, and then your friend is running this play, okay? And we want to know if your friend actually made a 90-degree turn. So from starting here to here and coming down to the end zone, was this 90 degrees? Okay. And each unit of the grid is representing 10 feet. So what we need to do first is use the distance formula to find the length of all three sides. So this first distance, okay, distance 1, is the square root of the difference of the x's, okay, which will be 60 minus 30 squared, plus the difference of the y's, 50 minus 20 squared. Okay, so that is 30 squared plus 30 squared. Okay, and that will be 900 plus 900. So it's the square root of 1800 feet for distance 1. Okay, now distance 2 from here to here, okay, is going to be the square root of 80 minus 30 squared plus negative 30 minus 20 squared. Okay. And then when we do that, we're getting 50 squared plus negative 50 squared. Okay, so that's 2500 plus 2500, and the square root of that, which equals the square root of 5,000 feet for the distance of the second between the second 2 points. And finally, distance 3, okay, is the square root of 60 minus 80, or we can do 80 minus 60 actually, because we don't want to be dealing with negatives that way. So 80 minus 60 squared plus negative 30 minus 50 squared. So 20 squared plus negative 80 squared, okay, which is the square root of both of them, so 400 plus, sorry, 6,400, okay, square root of that, so that'll be the square root of 6,800 feet. Hello. And what we need to do now that we have those three distances is to see, using the converse of the Pythagorean theorem, whether that actually forms a right angle. Okay, so doing that, we are actually given that the a squared would be either the square root of 180 or the square root of 500. So it's the square root of 1800 squared, okay, plus the square root of 5,000 squared. Does that equal the square root of 6,800 squared? Okay, if this is true, then that is a right angle, and then the player would have ran a 90-degree turn. Now, the square root of anything squared are inverses, so that's just 1800 plus 5,000. Oops, and does that equal 6,800? Well, 1800 plus 5,000 is 6,800. So, yes, since this is true, the sides form a right angle. Okay, it's a right angle. So, yes, the player ran a 90 degrees turn. Okay, and that would be your solution here. So a lot of work for that one problem. I had to use the distance formula 3 times and then use the converse to the Pythagorean theorem to make sure it was a right angle. Alright, sorry past your practice problems here. What you're going to do, there's only 4. The first 2, you're not actually given a picture of a triangle, but you're given the 3 sides. Remember that the longest side in the triangle has to be your C value, the hypotenuse. And so you're just going to use the converse of the Pythagorean theorem and see if those sides actually would form a right triangle. Does it make the Pythagorean theorem true in that case? Remember, again, the longest side is your C value. And then you have to use the distance formula to try to find the distance between the 2 points in 3 and 4. And you can keep your answer as a square root. Unless it's a perfect square, then you can evaluate it. Great, please make sure you write down any questions you have, and have a great night.